learning about antiderivatives, you might be thinking, why on earth do I need an antiderivative? I know why I need a derivative to help me find maximums and minimums to solve related rates and optimization, beautiful things. But why on earth do I need to go backwards? Let's talk about that here. So, in this problem here, we're given the acceleration formula, and we want to know the position formula. So I know the acceleration. How do I find the particle's position? We have to go backwards. So we're at the second derivative. That means I have to find the first derivative, and then I have to find the original function. We're just going in reverse. So let's dive in. From acceleration, the next thing I'm going to find is velocity. So I'm going to take the antiderivative of 8t, which is going to be 4t squared. And the antiderivative of negative 3 is negative 3t. But again, I could have had a constant here, so I have to add plus c. This is when my initial condition comes into play. I've been given at time 0, my velocity is 4. So I can go ahead and plug in 0 for my time. And it's going to spit out 4. Well, this is 0, this is 0. So I now know the constant in my velocity is 4. So my velocity formula is 4t squared minus 3t plus 4. Now I have velocity. I have to go one more step to get position. So I'm going to take the antiderivative here. So now I'm going to get my position formula, which is 4t cubed over 3 minus 3t squared over 2 plus 4t. And then again, I need that c. I don't know if there was a constant. And again, I'm given an initial condition to find that. So when time is 0, my position is 1. So I'm going to plug that in here. When time is 0, don't mind me, I'm going to take some shortcuts here. 0 minus 0 plus c is 1. So in this case, we know c is 1. So my position formula is 4t cubed over 3 minus 3t squared over 2 plus 4t plus 1. So that's my position formula, and there's the acceleration. So we could take the derivative, go back to velocity, take the derivative of velocity, and we'd be back at acceleration. Nifty, yeah? Okay, another way that they can phrase this, same setup, same process, is they could ask us to find the particular solution. So the original function. We know the second derivative, but I want to know the original. So we got to work backwards. So remember, this is notation for second derivative. So now I'm solving for the first derivative by taking the antiderivative. So 12x cubed, that's going to give me that's 12x squared. That's going to give me 4x cubed plus c. With this example, I'm only given x's and y's. I don't know the slope. I only know two positions. So I can't solve for c until I'm in my original function. So we're going to go ahead and take the antiderivative of this unknown. So y equals, antiderive this, and I'm going to get x to the 4th plus cx plus d. I have two unknowns now. I didn't know the constant here, but now it's attached to an x, and I have another constant. This first initial condition is going to help me solve for one of those variables. So if I know that y equals 1 when x equals 0, 0, 0, I now know that d equals 1. So we have y equals x to the 4th plus cx plus 1. And now I can solve for C with my second initial condition. I know that when x equals 3, y equals 8. So I'm going to plug that in here. 8 equals 3 to the 4th plus c times 3 plus 1. Ooh, 3 to the 4th. That's 81, right? Right? Okay? Because 3 squared is 9, so that's 9 times 9, yep. So 8 equals 81 plus 1, that's 82, plus c times 3. So I'm going to minus the 82 over. Mental math. 1, 2, 6, 74. So this is negative 74 equals 3c. Divide by 3. Sorry, you can hardly see that. I'm going to get c equals I don't think that goes in nice. I think that's going to just be negative 74 thirds. Unless I've done something wonky. That's where we're sitting. So my particular solution here is y equals x to the 4th minus 74 thirds x plus 1. Hopefully I did that one right. That's a weird number, but this is 81 plus 1. Minus that over, that's 1, 2, 6, 74. Divide that by 3. Okay, good luck. I'm going to double check this and hopefully I did it right.